Hello everyone. So we have got this very good question from the chapter of complex numbers. So at first this question looks very weird. I mean, we have got p's and m's and we have been asked to find the actual value which will be a whole number for this particular question. So let me write this question first. It's slightly unclear right now. It is pi to the power m multiplied by e to the power 2mi cot inverse p. Yeah, let me just check it once. 2mi cot inverse p. Yeah. So we are used to seeing this particular term, e to the power I theta, which is equal to cos theta plus I sin theta, right? And we have been given cot inverse p over here. So if we replace p by cot theta, we will get a term like 2mi cot theta. I'm sorry, 2mi theta, right? So that is kind of familiar because then 2mi theta we can reduce this like cos 2m theta plus I sine 2m theta, right? So yeah, let's place p equal to cot theta in this particular question. Yeah, okay. So if you put p equal to cot theta, it will be I cot theta plus 1 divided by I cot theta minus 1. First, let me solve this term first, this pi term first, then I'll go to the e to the power term later on. Okay. So cot theta is cos theta by sin theta. So we can write this like this, yeah, sin theta plus I cos theta divided by minus sin theta plus I cos theta. Now this term looks slightly weird because we are used to seeing cos theta plus I sin theta, right? So let's try to convert this term into that cos theta plus I sin theta term. No, only in that particular case will we get something related to e to the power I theta, right? So let's do one thing. Let me multiply both the numerator and the denominator with I. So in that case, I will get minus cos theta plus I sin theta divided by uh, when we multiply I with I, it will be minus 1, right? And we already have a minus before sign. So this will be cos theta plus I sin theta, right? Now if we take minus common from minus I sin theta, this divided by cos theta plus I sin theta. All right. So the uh, the denominator we can write e to the power I theta. We also have power m outside. I'll update that. I'll write that later. Let's do one thing. We have got. We need to bring it. We need to do something to make this particular term as plus, right? So if we place theta with minus theta, cos theta will not be unaffected, but sine minus theta is minus sine theta, right? So I'm sorry. Right? We can write this and we can write this as e to the power I theta. Okay. And we can, the numerator, we can write e to the power minus I theta. And in the denominator, we when we bring that to the numerator, it will become minus I theta as well. So this essentially becomes e to the power minus 2I theta. And from the very beginning, we have got a to the power m over here, right? Right, I'm not writing it every step. So let me do one thing. I'm so sorry. I don't know, my stylus is not working properly. Yeah, so let me multiply this with m. So this will be minus 2I m theta. Now, this e to the power term, observe it carefully. This term is basically e to the power 2 mi theta, right? So, this question is essentially solved right now. Yeah, that's what you have got your answer, right? This is equal to 1. So, a very complicated, so when you will be appearing in advance, you can expect most of the questions to be unknown to you, right? And you have to use your intuition and you have to use common sense in order to solve those sums. Okay, they will appear very, very difficult, but they're actually very easy. Like, this is the first thing that you have to see. You have got e to the power I theta, something of that form. So you can reduce that to cos theta plus I sine theta and vice versa, right? When you put p equal to cot theta, you will get something in the form of cos theta plus I sine theta over here. So these are things which you will observe when you practice a lot. Okay, you will start observing them automatically when you start practicing them a lot. All right, thank you.